In this design criteria lesson, we're going to start to talk about our component selection. After completing this lesson, you'll be able to understand multi-rotor component basics. So first we want to talk about the basic parts of a multi-rotor. When I say multi-rotor, it's a general category of a multiple rotor flying device. So in most cases, you're going to talk about a quadcopter, which is what we're designing and has 4 motors. Now, some cases you might have a tricopter, which has 3, or a hex, or an octocopter, or some other configuration. Now, we've already talked about these in our introduction, but in general, all of these fall into the category of a multi-rotor, and they're all going to have the same equipment. Now, in our case, the first thing is going to be a frame or a body that holds all of the things together so that we can fly it. Now, that's the entire point of our course, is to design and engineer, manufacture our body so that we can have a custom device, a custom quadcopter that we can use for our intended purpose. Now, you can buy a lot of off-the-shelf frames and build your own, and I will actually suggest during the course to buy some of these off-the-shelf racing drone frames to do as a test platform as we figure out all the components and the controls. The next thing is going to be the motors and the propellers. Now, there are a lot of variables here, and we're going to talk about some basics to understand, and we're going to talk about some specifics when planning out a build. Now, the entire point of our course is to design a 3D printed body for a disaster relief drone or a disaster search drone. But we want to make sure that you have all of the information to not only do that portion of the course, but to also plan out your own build. Because that's the entire point here, is to understand the design process, and here is specifically the design process as it applies to designing a quadcopter. So the motors and propellers, a lot of variables, we're going to talk about those in generalities, and then we're going to talk about specifics and calculations. Batteries, again, also lots of variables when you start to plan out a build with batteries. We'll talk about what the numbers on a battery mean. We'll talk about how to plan them into your build and how changes in the batteries will affect things. The flight controller. Again, when you're talking about multi-rotors or quadcopters specifically, there is no shortage of flight controllers out there. We have a specific one we're using because of its small size, but I'll talk about some others in general and what different options you might see when you start to plan out a build. An ESC, or electronic speed controller, is another important part of this type of build. It's going to take the information from the flight controller and it's going to convert it into something that the motor needs. The motors that we're using are going to be brushless motors, and they need a specific type of signal in order to turn and spin and be useful. The next thing is a PDB, or a power distribution board. Now, these aren't generally needed on all types of multi-rotors or quadcopters, but it's a nice piece of tech to have because it allows us to bring in our battery voltage, and it does a few things for us. It converts it down to 5 volts as well as 12 volt regulated or just unregulated input power, and allows us to take that power out to our ESCs, to all of our motors. It also allows us to do custom things like send 5 volts out to the camera or send 12 volts out to some other components. And again, we'll talk about the specifics of all those and how many different PDBs are out there on the market. In some builds, you might use an electronic speed controller that has what's called a battery eliminator circuit, in which case you can hook battery power directly up to the number 1 ESC, and then from there you can actually wire it up so that you don't need a power distribution board. In our case, we're using a power distribution board specifically because we have a camera, a transmitter, and some other components, but again, it's not necessarily needed on all quadcopters. A controller and a receiver is a necessity in our case because we're having a quadcopter that's completely flown by a controller on the ground. There are cases where you can design one to fly by itself based on GPS coordinates and waypoints, but in our case, we have a remotely piloted vehicle. So that means we're going to have a controller, a person on the ground that's controlling it directly, and the receiver on our quadcopter. The next thing in our specific case is a camera, TX, and tilt motor. Now, the TX part of the camera is a transmitter. So it's going to take our camera signal and it's going to send it down to us so we can view it on a monitor. The tilt motor can be a servo or a brushless gimbal motor, but in general, we're going to be using a tilt motor so that we can take the camera and tilt it up or down based on what we want to look at. So these are the basic components or basic parts of most multi-rotors. Now this does also fall in line with various other types of vehicles. A lot of this can apply directly to ground vehicles as well. So if you're using this course and you're trying to plan out a build, whether it's a quadcopter or an airplane or some other vehicle like a car or an RC truck, a lot of this is going to directly translate to those as well. The flight controller that we use can be used on airplanes, it can be used on ground vehicles or boats or motorcycles as well. So it all will directly apply to all of those categories. So now the last thing I want to talk about in this lesson is the big picture. And understanding the big picture helps us understand what these components do and how it helps us plan them out. So the overall weight of any flying vehicle is extremely important. You can't make a very heavy flying vehicle and have it fly for a long time and be maneuverable, all the different things that we need in our design criteria. So as we look at the overall weight, the batteries that I've planned to talk about in this course are between 100 and 300 grams each. Now we'll get into picking the components later and what it all means, but right now all you need to know is that we're going to be using 2 batteries. So we're looking at generally 200 to 600 grams total weight on our vehicle. The components that we're using, which includes the motors, the props, the speed controllers, the power distribution board, the flight controller, the receiver, all the other stuff that's not the batteries, that's going to be between 200 and 300 grams. The reason I gave a range there is because we can mix and match parts, we can change things out and have a big effect on that weight. Now we're going to be shooting for the 300 gram range, but again, there's a range there because you can use different cameras. You can remove the tilt servo and have a fixed camera. We can maybe change out our power distribution board. Different things like this can have an effect on them. And lastly, we have the body, which I have to be determined. Now, in general, when you're planning out a quadcopter, it's a good rule of thumb to have your battery weight be between 50 and 65% of the overall vehicle weight. Now, there's no hard and fast rule that it has to be that, but in general, when you get your batteries over about 65% of the overall vehicle weight, you're really just adding more weight to spin the motors to carry the weight of the batteries. So there's a fine line between that 50 and 65% where you're not really adding anything additional to the flight of the vehicle, in this case our quadcopter. So if we look at this, and again remember we're using 2 batteries, we're looking at 600 grams of batteries, 300 grams of components. So to keep with that roughly 50% rule, we're going to be looking at roughly 300 grams for the body. So that's going to be our starting point and our target for the design body. Of course, if we can make it lighter, that's better because we can add more components and still have the same thrust ratio. The next thing that we want to talk about in the big picture is the thrust, because this is actually the force that gets us off the ground. Now the thrust comes down to 3 main factors: the propeller size, the battery configuration, and the motor we choose. Now the reason all these are important is because all 3 of them go together. Now certain motors are specifically designed for certain propeller sizes. The motor that we're going to be using is generally used on 5 or 6-inch propellers, but it's only used on 6-inch propellers in certain battery configurations and 5 in other battery configurations. This information comes directly from the motor manufacturer, and you can also test it by building a test rig with a scale and a restrained motor. But for right now, we're going to be using the information that comes directly from the manufacturer and comparing how changes in the battery and the prop size will affect the thrust that we get. Because remember, we're planning for 600 grams of battery, 300 component, and roughly a 300 gram body. So that value, that 1200 grams, is what we're looking at for the amount of thrust that we need. And we're going to plan all that out, and we're going to talk about those in general and specifically in other videos.